Hello everyone, I'm Leroy Thompson. I'm one of the 8th grade math teachers here at Texas Virtual Academy. There are 3 of us now. We have Dr. Sanchez, myself, and Mrs. Frink. Last week you had the opportunity to meet Mrs. Frink on her video, and next week you'll get a chance to meet Dr. Sanchez. Last week we discussed how to compare and order numbers. Well, this week we're going to take a look at irrational numbers and how can we compare irrational numbers. Well, in order to deal with irrational numbers, you first have to understand what a rational number is. A rational number is any number that can be defined as a fraction, as long as the denominator, that's the bottom number, is not 0. So if we can turn any number into a fraction, it's rational. However, if we have a number that cannot be turned into a fraction, in other words, it's not a repeating decimal and it's not a terminating decimal, it therefore is irrational. An example of one of these irrational numbers that you should be familiar with right now is pi. Pi is 3.14, and it goes on indefinitely. It's never been able to be finished dividing. That decimal never terminates, and that decimal never repeats. So therefore it's irrational. Well, when we're talking about most irrational numbers, we're talking about the square root of numbers. Well, obviously there are some square roots that are rational. For example, the square root of 1 is 1, because 1 times 1 is 1. And we know the square root of 4 is 2, because 2 times 2 gives us 4. The square root of 9 is 3, because 3 times 3 is 9. So those squares, those square roots, are rational. However, we have some square roots that there's no rationale to it. They cannot be divided into 2 exact numbers. An example of one of these could be like the number 15. If we look at 15, if we try to find 2 numbers that we can multiply together to equal 15, and those 2 numbers were the exact 2 numbers, we couldn't do it. So how do we go about finding out approximately what that number can be? Well, if we take a look at 15 and we want to find the square root of it, we need to find 2 perfect square roots that are on either side of it. For example, the square root of 16 is just past the square root of 15, and the square root of 16 is 4. So we know the number that we're going to have has got to be less than 4, because 4 squared gives us 16. So if we go down to a square that is below 15, that would be the square root of 9. Well, the square root of 9 is 3. That means our number lies between 3 and 4. But because the square root of 15 is so close to the square root of 16, that tells us that our number is going to be greater than 3.5. And see, we can estimate then that the approximate value of the square root of 15 is greater than 3.5, but less than 4. And if we wanted to, we can even break it down even to 2 or 3 place values in the decimal portion, if we wanted to. Okay, but then we'd have to do it by trial and error. Hopefully this gives you a brief insight as to irrational numbers that we're going to be studying this week. So get into your study island, take a look at 1B, irrational numbers, and it should give you a further explanation of what I was trying to explain on this video. Thank you, have a great weekend, and we'll see you next week.